Hello dear students. So I welcome you all in this new session where we are going to discuss some physics problems, okay? So you all already know the name of the paper, right? This is AIATS Plus 2025 Phase 2 and the name of the paper is Mock Test 9 and it was conducted on 16th of March 2025, right? So these are the chapters which we are going to discuss. Oscillations and waves, these are the last two chapters of your 11th class, and ray optics and optical instruments, wave optics, magnetism and matter, and semiconductor. These are from 12th class. So variety of chapters which we are going to discuss today, right? And we are not just going to solve some problems only, we are going to build concepts around them. So let's see the first question. Hello Yamraj, Lucky, good afternoon everyone. Okay, so let's start then. The first question says, a standing wave produced in a stretched string 0.2 meter long is stretched at both ends has fundamental frequency 500 Hertz, right? The velocity of the transverse wave in the string will be nearly. So we are given with the length of the string, right? Frequency of the string or the frequency of the wave. Now we have to find the velocity of the transverse wave which is moving on this string, right? So we know that V is equal to lambda into F, right? These are the three properties or the three parameters which are associated with any wave. What is V? V is speed of wave, lambda is wavelength, and F is frequency. Now, frequency is the property of the source. We already know that, right? In this case, standing wave is produced, and this is the fundamental frequency. So what about the fundamental frequency? Why it is given as fundamental frequency? Because let's say this is the string which is connected at both the ends, right? So the fundamental frequency of this string will look like this, or the fundamental mode of this string will look like this, right? So there will be two knots at these two ends and one antinode here. Any problem so far? Okay, Lucky. So you are giving me the answer. This is 400 meter per second. Let's see. So this is antinode and this is node 1 and this is node 2, right? Now, if this is the length, this is L, then tell me what will be the wavelength. So as you can see, this is half the wave, right? The full wave would look like this, right? So this is half of the wave. So lambda L is equal to lambda by 2. So lambda will be equal to 2L. Now length is given as 0.2 meter. So lambda will become 0.2 into 2, that is equal to 0.4 meters. And what about the frequency? Frequency is given as 500 Hertz. So frequency is 500 Hertz. Now I know the frequency, I know the wavelength, then the speed of the wave can be easily found with this formula, lambda into F, that is equal to 0.4 into 500, right? So this will become, this will give me 10 and this 0 will get cancelled out, 50 into 4, that is equal to 200 meter per second, right? So Lucky, got the answer now? So the answer should be 200 meter per second. That should be the answer, right? The velocity of the transverse wave in the string will be nearly, that will be equal to 200 meter per second. Now, let's see some more concepts around it. So this was the string which was connected at both the ends, right? What if all the information is exactly same, but the string is attached at one end only? Then what will happen? So the string will look like this. This is connected at one end and this is an open end, right? Then the fundamental mode will look like this. There will be one node and one antinode. This will be antinode, right? Now what will happen? If this is L, this is L, then L is equal to what? Lambda by 2 or lambda by 4? It will be equal to lambda by 4, right? So lambda will be equal to 4 times L, that will be equal to 0.2 into 4, this will become 0.8 meter. Now if the frequency is same, let's say the frequency is exactly same, that is 500 hertz. Now what will happen? What will be the velocity? This velocity will be equal to lambda into f, that is equal to 0.8 into 500. Now this will give me answer as 400 meter per second. So Lucky, you have given me the answer of this question, right? Right, Padmavati? Got it? So if the question is like this, then the answer would be 400 meter per second, and if the question was like this, then the answer should be 200 meter per second. Any doubt in this question so far? No? Let's move to another question then. So the question number 4 says, a particle is executing SHM according to equation x is equal to a sin omega t. The phase of particle at x is equal to a by 2 while moving towards positive extreme position is. This is the equation, or this is the equation which is of SHM, right? X is equal to a sin omega t. Now tell me what this equation signifies. So x is equal to a sin omega t is the equation of SHM where the particle is starting from its mean position at t equal to 0. You can put t equal to 0 and you will see that x is equal to a sin omega t. At t equal to 0, this will become sin 0, right? And sin 0 is equal to 0. So x is equal to 0. But the at x is equal to 0, the particle might be going like this or like this, right? So now you have to understand that x is equal to a sin omega t will give me the motion of the particle which is going towards this. Okay. So x is equal to a sin omega t will be the equation of the particle which is at mean position and it is going like this. Okay. So the motion would look like this. Okay. Now the phase of the particle at x is equal to a by 2. So we have to find the phase of the particle, and what is phase now? This is a sin omega t, right? This is known as phase. This is phase. And will this phase be constant or variable? Right? Will this phase be constant or variable? This would be variable, right? Because this is time dependent. Omega is constant and t is time here. So this phase would be time dependent. So we have to find the phase of the particle when the particle is at x is equal to a by 2. Again, at x is equal to, this is a, right? This is a, or this a is amplitude, right? So if this a is amplitude, so this I can write it as that this is end point or extreme point, and this is x is equal to a. Now we have to find the phase of the particle when it is at x is equal to a by 2. Now at x is equal to a by 2, again the same problem will be there, that the particle might be moving like this or be moving like this, and in both the cases the phase would be different. Okay. So we have to find the phase when the particle is at x is equal to a by 2 and it is moving towards positive extreme, means this condition we have to deal, right? Okay. Now x is equal to a by 2. It means whatever be the equation, if I put some time t here, then the phase should be like that it will give me x is equal to a by 2 as the position of the particle, right? So x is equal to a sin omega t, right? This is the equation. Let's take another slide. So x is equal to a sin omega t. This is the equation. X is equal to a by 2, right? So this is x is equal to a by 2 will be equal to a sin omega t. Now this a will be cancelled with this a, right? So this will give me as sin omega t is equal to 1 by 2, and what is 1 by 2? That is equal to sin 30 degree, that is sin pi by 6. So omega t will be equal to pi by 6. Is this the answer? Obviously, right? Because this is the phase, right? This is the phase of that equation, so that would be equal to pi by 6. So the answer is pi by 6. Very easy. But now you have to tell me, if the same question says that particle is at x is equal to a by 2, but it is going towards what? Negative extreme. Now what should be the answer? Okay, this is new condition. Particle is, this is x is equal to 0, let's say, this is x is equal to a by 2. Particle is at x is equal to a by 2, but it is going towards negative extreme. Now, what would be the answer? How can we find it? Okay, so you have to remember that if x is equal to a sine omega t is our fundamental equation, then if the particle is at this position, x is equal to a, है ना? So if the particle is starting from the mean position and the particle reaches here at x is equal to a, then the phase would become, here the phase would be pi by 2. Okay, there are, see, one oscillation is completed like this. If the particle starts from here, then it will go from mean to this extreme, right? This would be 1/4 of the oscillation. Then the particle will come from this end position or extreme position again to mean position, right? This will again complete 1/4 of the oscillation. So 1/4 and 1/4. This is half oscillation. Now the particle is at this position and it will go to this extreme, negative extreme. This will again complete my 1/4 of the oscillation. Okay, and this would be from extreme to mean, again 1/4 of the oscillation. So this is complete oscillation. Now, in one oscillation there is 360 degree or 2 pi. All right. So if this is 1/4 of the oscillation, then 2 pi by 4, that is equal to pi by 2. So this is the phase which will change from this position to this position. Okay. That is why if the particle comes here, then the equation will become x is equal to a sine omega t, or I can write it as pi by 2, है ना? This will become pi by 2. That is why sine pi by 2 will become sine 90, that is equal to 1. So x is equal to a. This would be the equation. Okay. Now, okay, you understood this part now. So you have to tell me the equation or the phase of the particle when it is at x is equal to a by 2 and it is moving towards negative. Okay, so Lucky, you are giving me the answer as 3 pi by 4. Any other answer? All the students, all the present students, tell me your answer. What should be the answer? No? Okay. So let's find out what should be the answer. Okay. So x is equal to a sine omega t. Now again, I need a by 2, but the particle should be going towards negative, right? So a sine pi by 2 plus pi by 3. Why I am writing this? Because x is equal to a sine omega t is our fundamental equation. Okay. I need x is equal to a by 2. I already know that the particle is already reached here. Yeah, right? So it has completed this pi by 2 motion already. That's why sine pi by 2 plus, now when I will write sine 90 plus theta, it will become cos theta, right? So it will become cos theta. So sine 90 plus theta will become cos theta. So it will become cos pi by 3, and cos pi by 3 is equal to a by 2. Okay. If I write here pi by 2 plus pi by 6, then it will become cos pi by 6, and cos pi by 6 is equal to root 3 by 2. Then I will not get my answer. Okay. That's why I have manipulated it like this. So this phase will become pi by 2 plus pi by 3. Tell me the answer. This is 3, 2. The LCM would be 6. This is 3. This is 2. The answer will be 5 pi by 6. Lucky, are you getting this? So the answer is 5 pi by 6, not 3 pi by 4. Okay, write 3 pi by 4 in place of omega t. You will not get the answer as x is equal to a by 2. Okay, sine 3 pi by 4 will become sine pi by 2 plus pi by 4. Sine 90 plus theta will become cos pi by 4, and cos pi by 4 will be equal to 1 by root 2. So you will get the answer as a by root 2, not equal to a by 2. Okay. Any doubts so far? So we have already solved this question now. So the answer was pi by 6. Okay, let's move to another question then. Question number 15 says, when a ray of light enters from rarer to denser medium, it bends towards the normal. Obviously, right? It bends towards the normal. Statement 1 is correct. No need to discuss anything in this. Statement 2 says, when a ray of light enters from rarer to denser medium, its frequency decreases. No, frequency does not decrease or it does not change, right? It remains constant. Why? Because frequency is the property of source, right? So since it is a property of source, it cannot be changed afterwards. Okay, so frequency remains constant. That's why this is a wrong statement. So statement 1 is correct and statement 2 is incorrect. What should be the answer? The answer is 2. Statement 1 is correct and statement 2 is incorrect. Okay, let's see some concepts here. So we know that mu, that is equal to refractive index, is equal to C by V, right? And C is the speed of light in vacuum. So C can be written as lambda in the vacuum into frequency. So I am writing it as lambda vacuum, okay? Lambda vacuum into frequency in vacuum. Okay, again, V can be written as, this V is speed in some medium, any medium. So I can write lambda as medium into frequency in medium. Since we know that the frequency in vacuum and frequency in medium will remain same, that's why this will get cancelled out. Okay, so C by V or mu can be written as, refractive index can be written in terms of speed. It can also be written as in terms of what? Wavelengths, right? So if we know the wavelength of any light or any electromagnetic wave in vacuum as well as in medium, then we can also find the refractive index from that too, right? Now, if this is C by V, this is equal to C by V, and speed of light in vacuum is greatest, right? Greatest, that is equal to 3 into 10 raised to power 8 meter per second. It will not be greater than that, right? So speed of anything of light in any medium should be less than C, right? So V is less than C. If V is less than C, then tell me this denominator is less than this numerator. Mu will always be greater than what? Greater than 1. It can only be equal to 1 in vacuum, or sometimes we approximately we say that the mu is equal to 1 for air too, right? Because the speed of light in air is also almost equal to speed of light in vacuum. That's why mu is almost equal to 1 for air too, right? Mu is equal to 4 by 3 for water and mu is equal to 3 by 2 is for glass, right? So mu is always greater than or equal to 1, right? Now, C remains constant, V is changing, right? That's why lambda medium will be different from lambda vacuum. That's why wavelength change and frequency doesn't, because speed of light in different medium is different. That's why wavelength of light of that same whatever frequency that is, that will change, okay? Mu never less than 1, yes Lucky, okay? Mu can never be less than 1. It can only be equal to 1 in case of air and as well as vacuum, but it has to be always greater than 1. Any doubt here? No? Let's move to another question then. Okay, question number 19 from the semiconductor obviously, and this topic or this logic gate questions can be asked in the exam too, right? So which logic gate is represented by the following combination of logic gates? So we have to tell the resultant logic gate which is formed from, by this combination of different logic gates, right? What is this? Which gate is this? This is NOT gate, right? NOT. What happens with this gate? Whatever be the input, it will give the opposite output, right? So if the input is A, we will get A bar. If the input is B, we will get B bar, right? So this you know, right? What is this? Which gate is this? Anyone? Lucky? Which gate is this? NOR? This one, this one. Riddhi Brata? Yamraj? You were also there, right, initially? Which gate is this? This is NAND. This is AND, na? This one is AND gate, right? If there is this dot, this will become NAND. Okay, so this is NAND. Now let's solve this. Yes, Riti Bharta, very good. So this is NOT and this is NAND. We have to find the resultant gate from this. So let's see what we will get. This is A, this is B, and the output is Y. Okay, this is A. What will happen with A? This will become A bar here. This will become B bar here. Okay, so far so good. Now, the input of this NAND gate is A bar and B bar. What will happen here? This A bar and B bar would look like this. A bar. This is AND dot B bar, right? These are the inputs here. And since there is this NOT gate here, it is NAND, so there will be one more bar here. This is the output. Anybody? Any problem in this? Are you getting this? So Y has to be equal to A bar dot B bar ka whole bar. Should we solve it by checking the truth table? Riti Prata, yes, we can do that too. Okay, beta? We can do that too. Okay, so Y is equal to this. Now we have to transform this. So that there are different identities in the semiconductor. We can solve this as A bar plus B bar, and the bar will come like this. Okay, A bar dot B bar ka whole bar. This is whole bar, na? So after solving this, we can write it as A bar plus B bar, and the bar will get distributed on these two inputs. So this will become what? A plus B. Bar and bar will get cancelled out, right? Truth table lengthy हो जाएगा. Yes, Lucky. बिल्कुल. Truth table lengthy हो जाएगा. That's why we can solve this with this also, and it may be possible that in this case truth table method is also almost same, will take almost same time, but when there are multiple logic gates, right? If there are logic gates as 4 and 5, then that will become a lengthy process. Then you can solve this that kind of questions with this logic. Okay, so this is A plus B. Yes, Lucky. And this A plus B is OR gate. Okay, so this is OR. This is the answer. Option 1 has OR gate here. Any doubt? Lucky, Riddhi Brata, any other student? Any doubt here? No? Let's move to another question then. A magnetic needle of magnetic moment M is making an angle of 45 degrees with the direction of uniform magnetic field B. Okay, so there is a magnetic needle and the magnetic moment of that needle is M. And this is making an angle of 45 degrees with the direction of uniform magnetic field B. The torque needed to maintain the needle in this position will be. Why do we need torque to maintain this needle in this position? Why? We will need torque because the torque is applied by this magnetic field on this magnetic needle, right? So we have to apply the counter torque. Okay, you are giving me the answer. Very nice, very nice. Okay, we will see. So let's say this is magnetic field B in this direction. Okay, so there is this magnetic field everywhere. This is magnetic field B, which is uniform, right? And the magnetic needle is making some angle theta. Let's say this is magnetic needle and this is the magnetic moment. Magnetic moment is a vector quantity, right? So the direction of the magnetic moment is like this and the direction of magnetic field is like this. If the angle between them is theta, then I can write tau, which is also a vector quantity, can be written as M cross B, right? Or in terms of angle theta, we can write MB sine theta, and I have to apply this unit vector here, so n cap, MB sine theta into n cap. Okay, we can find it very easily now, since we know that torque would be equal to M, which is equal to M already, it is given in the form of M. B is, the magnitude of B is B, and the angle between them is 45, so this will become sine 45 degree. Since I am talking about the magnitude here, so I am not writing this n cap here. So this will become M B sine 45, that is equal to 1 by root 2, MB by root 2. Okay. Now in this exact question, so this is the answer, MB by root 2. In this question, if it is given that there is a coil, okay, which is carrying some current, let's say I, and the radius of the coil is, say, A, small a. Okay, now this is magnetic field B. It is like this, and a coil is placed like this. Okay, so coil is like this. This is coil. Okay, we are seeing, or we are observing this cross section like this, or the view of this is like this. Okay, so this is the coil here. So plane of the coil is making some angle, and this is, let's say, theta. Now what would be your answer? Or let's take some values here. So this theta is 30 degree. Now, and the magnetic moment of this coil is M, and the magnetic field is B. Now what will happen? We have to find the torque. So tau is equal to, again, mu cross B. The formula will remain same, because we know that the magnetic moment of this coil would be some vector M. So M vector is here, or mu vector is here, magnetic field is B. The plane of the coil is making some angle, theta is equal to 30 degree. Now what will happen? See, in the first case, it was a magnetic needle, and its magnetic moment is this, was in this direction. But in this case, if this is a coil, then we know that for a coil, its magnetic moment is perpendicular to its plane, right? So its magnetic moment would be in this direction, not in this direction. Okay, not in this direction. Its magnetic moment would be in this direction, which is equal to, yeah, very nice, Lucky, very good. So this would not be equal to what? This would not be equal to theta equal to 30 degree. It would be equal to, because this is 90 degree, na? If this is 90 degree, this is theta, which is 30 degree. So the angle between magnetic moment, that is this M vector, and magnetic field B, which is this, so this will be equal to 60 degree. So I have to write tau is equal to M magnetic moment, the magnitude of the magnetic moment, B, and that's would be equal to sine 60 MB into root 3 by 2. Okay, I am discussing this question because it would make you confused. Problem is that here it is given as magnetic needle, but in some conditions you are given with this coil also. Okay, now you can deal that kind of problem where you have given with the coil. Okay, any doubt here? Any doubt here? No? Let's see another question. A beam of light of wavelength lambda, that is equal to 500 nanometer from a distant source, falls on a single slit 1 mm wide, and the resulting diffraction, okay, the question is from diffraction. Diffraction pattern is observed on a screen 2 meter away. The width of central maxima is, we have to find the central maxima, but what is given? Lambda is equal to 500 nanometer. This is the light which we are using as a source, right? This is the slit which is equal to 1 mm, and distance which is denoted by capital D, that is equal to 2 meter away, width of the central maxima. So what happens is, if this is a screen, and this is a slit, see, slit is very small, but I am making this big here. Okay, this is the slit. Now what happens is, we take two wavelets from here and here, from the endpoints. This is the central line. This is the central line. Now, if light rays from here will reach here, then this is the central maxima. Why central maxima? Because there would be no path difference, right? There would be no path difference from these two lights. That's why there would be constructive interference and we will get a central maxima here. But in case of single slit, you get a central maxima for quite a width. Okay, there is some sufficient width for which we get bright spot here. Okay, so what should be the width of the central maxima? So what should be the width of the central maxima? The width of the central maxima would be that if at some position, let's say this position, this is say y1 position, if I am getting a dark fringe here or the darkest point here, similarly I am getting a darkest point here, that due to symmetry you will see that this, if this is length y1, this would be equal to y1, right? So that is the width of the central maxima we have to find. Okay, for the central maxima there would be no path difference. What about the first minima? What should be the this path difference? That would be equal to C. So let's say they are coming here, or let's say this y1 I am taking this much. Okay, so this is y1 now. Okay, so that we can do the calculations properly. That's why I am taking this big. This light will reach from this point. Okay, if this is the distance between these two, so this is A, which is slit width. Now as you can see, this is the line here, this is perpendicular, I am dropping a perpendicular here. Let's say this is angle theta. If this is angle theta, then this would be equal to what? A sine theta. A sine theta. And you will see that this A sine theta is equal to what? Path difference. Why? Because actually this screen is so far that the light from this and the light would from this will be almost parallel. So the length, okay. Okay. So actually there are so many students, Sirate Mustaqim, there are so many students which are from South India, so they cannot understand Hindi actually, okay. That's why I am trying to speak in English, okay. So I hope that you understand English too. So this is A sine theta is equal to delta x, fine. So A sine theta is equal to delta x. This path and this path is almost equal to, is equal, right? So this is A sine theta equal to delta x. Now, for the first minima, what should be the path difference from these two wavelets, for these two wavelets, and that is equal to what? Lambda. So A sine theta is equal to lambda. That would be the answer, okay? So we know that what is the value of A, what is the value of lambda. We have to find this sine theta. But now, this sine theta is equal to lambda. From figure, you can also see that this, if this is theta, then this is also theta. This is y and this distance is d. Okay. From this figure, you can see that sine theta and this theta is very small. So we can also write it as tan theta, and that would be equal to what? Y by d or y1 by d for us. Okay. ठीक है, तो sin theta is equal to tan theta is equal to y by d. Okay. Now If this is A sin theta is equal to lambda, sin theta can be written as lambda by A, and that is also equal to y by d. Okay, so now we have to find what? Theta, or the width. So sin theta can be written as lambda by A, which can also be written as almost theta, lambda by A. So theta is this, half theta, right? We know that point 1 would be here and point 2 would be here. So this is y1, then this is also y1. So this is also equal to theta. So the central width will be equal to 2 theta, right? So this will be width of central maxima will be equal to 2 theta, right? So this will be equal to 2 lambda by A. Now 2 lambda, what is the value of lambda? 500 nanometer. So 2 into 500 nanometer, that is equal to 10 raised to power minus 9, divided by A. What is A? A is 1 mm. So this is 1 into 10 raised to power minus 3. Okay. Lucky, it's okay. No need to fight with him. Okay, beta. No problem, no problem. Okay, focus here. So this will give me the answer as 2 mm. This is the width of the central maximum. Okay. I hope you got this derivation here, because this is quite important. You can use this derivation in Young's double slit experiment as well. Okay, so YDSE and diffraction are quite related to each other. You just have to remember that. Oh, in case of this diffraction, na, there is a pattern 0, delta x is equal to 0, or the path difference is 0, na, then we will get central maxima. Okay, then for lambda, 2 lambda, for lambda, 2 lambda, 3 lambda, these are for minima. Okay, these are for minima, and you have to like skip this lambda by 2 here. 3 lambda by 2, 5 lambda by 2, 7 lambda by 2. These are for secondary maxima. These are for secondary maxima. You have to skip this lambda by 2 here. For lambda by 2, we will get nothing. Okay. So for 0, we will get central maxima. For lambda, 2 lambda, 3 lambda, we will get minima. And for 3 lambda by 2, 5 lambda by 2, 7 lambda by 2, we will get secondary maxima. This is the difference between YDSE and diffraction. This is for diffraction. All right. Okay, let's move to another question then. So this is question number 26, which says two thin lengths of focal lengths f1 and f2 having powers p1 and p2 respectively are in contact and coaxial. The power of the combination is, we have to find the power of the combination of this. There are two thin lenses whose focal lengths are given as f1 and f2 and the powers as p1 and p2 respectively. We know the relation between power and focal length, that is equal to 1 by f. Okay, the answer given in power form also as well as in focal length also, right? So P is equal to P1 plus P2. If there are more than 2, then it could be P3, P4, whatever be the number of lenses. If they all are thin lenses, then the total this power of the combination is given as P1 plus P2 plus P3 plus P4. But here are only two this lenses, so it will become P is equal to P1 plus P2 in terms of power. So in terms of power, as you can see, this is not the option. This is not the correct option. So power should be equal to P1 plus P2, or I can write it as P is equal to 1 by F1 plus 1 by F2, right? Now 1 by F1 plus 1 by F2 is also not in this form. So I can write it as F1 plus F2 divided by F1, F2. Okay, we can solve this 1 by f1 plus 1 by f2. After taking LCM as f1 f2, this will become f1 plus f2. This is the answer which is given with, right? So f1 plus f2 divided by f1 f2, this is the correct option. So in terms of power, this is the answer. In terms of focal length, this is the answer. Okay? Yes, Lucky, very nice. Any doubt in this? No? Let's move. Very easy question, right? So let's move to another question then, and that is question number 32. If tube length of an astronomical telescope is 80 centimeter and its magnifying power is 15 for normal adjustment, because there are different kinds or different situations where the magnifying power could be different for this astronomical telescope. So here the tube length is 80 centimeter, magnifying power is this, and what is the condition? Normal adjustment condition, right? Then focal length of the objective lenses. Objective lens. So astronomical telescope has this objective lens. This is objective lens, and this eyepiece. Okay. The aperture of the objective lens is quite large with respect to this eyepiece in case of astronomical telescope. Okay. Focal length of this objective lens is f4. Focal length of this eyepiece is given as fe. Now, in case of normal adjustment, what would happen that for an astronomical telescope, the object is almost at infinity, right? So rays are coming like this. Parallel rays are coming like this. Okay. If rays are coming from like this, so the image would be formed at what? Its focal length, obviously. So this is f4. Now, for the normal adjustment, the image should form at infinity. Okay. To form the image at infinity, this image should form at focal length of this eyepiece. The image from the objective is formed at its focal length because the rays are coming from infinity, right? So it will be focused at focal length of this objective lens. Now, to form the image of this object, this is the new object for this eyepiece lens. Now, to form this image at infinity, the object should be at focal length of this eyepiece, right? So this will become fe. That's why the tube length, this is the tube length, right? So the length of the tube will be f0 plus fe, which is given as 80 centimeter. So this is 80 centimeter. This is equation number 1. What we have to find? We have to find the focal length of the objective lens. Here it is equation 1 where we have f0 and fe. There are two unknowns and one equation. We need one more equation. From where we can find one more equation? From magnifying power, obviously. So magnifying power in case of normal adjustment of this astronomical telescope can be written as f0 by fe, and it is equal to 15. Okay. So we can write f0 equal to 15 fe. This is equation number 2. We can solve these equations. Okay. So L is equal to f0 plus fe is equal to 80 centimeter, and f0 is equal to 15 times fe. I am writing f0 as 15 fe, so it will become 16 fe equal to 80 centimeter. Fe will be equal to what? 5 centimeter. We have to find f0, which is equal to 15 times fe, that is equal to 75 centimeter, and you can see the summation of 75 plus 5 will be equal to 80 centimeter, and that would be equal to the length of this tube or the astronomical telescope. Any doubt? Okay, very easy question. Just you have to remember these two formula. One is tube length in case of normal adjustment is equal to f0 plus fe, and the angular magnification is equal to f0 by fe. Not always, okay? This is the case where the object or the final image is formed at infinity. Okay, so it will form image like this at infinity. Any doubt? No doubt so far? Okay, let's see another question then. A particle is performing simple harmonic motion given by equation y equal to 4 sin omega t plus 3 cos omega t. Then the amplitude of the SHM will be. You have to find the amplitude of this equation or this SHM. Okay. If there is a general equation which is given as a sin omega t, just this one, then we know that the amplitude is this a. If I am given with this equation a sin omega t plus b sin omega t, then what would be the answer? If this is the equation a sin omega t plus b sin omega t, then what would be the answer? Anyone? The answer will be sin omega t can be taken out, so this will become a plus b sin omega t. This will be the amplitude. Okay, a plus b sin omega t. This is second type. Now, if we are given with this kind of equation a sin omega t plus b cos omega t, now what would be the answer? We can write it as under root of a square plus b square sin omega t plus phi. Okay, again this is a sine function, sin omega t plus phi. This is the amplitude, under root of a square plus b square. This is the amplitude. Now tell me, the equation which is given in question as 4 equal to 4 sin omega, y equal to 4 sin omega t plus 3 cos omega t is similar to this equation, right? This one, a sin omega t plus b cos omega t. That's why we have to apply this formula, under root of a square plus b square, and after solving this under root of a square plus b square, you will get 4 square plus 3 square. You know the answer, that is 5 units. 5 units is the answer. Any doubt? No? Okay, so let's move to another question then. Question number 39. A magnetizing field intensity of 1000 ampere per meter produces a magnetic flux density 0.25 Weber per meter square in a ferromagnetic substance. The relative permeability of ferromagnetic substance is approximately. Okay, we have to find the value of ferromagnetic relative permeability of ferromagnetic substance. Okay, so what we are given with this magnetizing field intensity, this is small h. It is denoted by small h, that capital H, sorry, and that is equal to 1000 ampere per meter. Magnetic flux density, this is magnetic field, nothing else. Okay, so this is B, which is equal to 0.25 Weber per meter square. Okay, in a ferromagnetic substance, relative permeability is mu r. We have to find this. Okay, what is the formula? Chanchal, Kumar Ahuja, how? Which one? Is there a doubt in the previous question? What is your doubt, Chanchal? Okay, so we have seen this, that this is equation number 1, which is quite fundamental, right? Y equal to a sin omega t. Now, if you are given with this equation, y equal to a sin omega t plus b sin omega t, okay, so sin omega t can be taken out. This will become a plus b. That would be the what? Amplitude. If the equation says that the SHM is happening like this, y equal to a sin omega t plus b cos omega t. Okay, so we have to solve this actually. See, a sin omega t plus b cos omega t, this is the method to make this as, you know that sin a plus b can be written as sin a cos b plus cos a sin b, right? We use this equation, so we try to form it like that, there is sin omega t already, this is cos omega t, right? So you can see that this is sin a, this could be written as sin a, and cos omega t could be written as cos a, right? Now I have to form cos b and sin b here, right? So if I have to form cos B and sin B here, this is the method that we have to y equal to a sin omega t. Okay, so I am rubbing this, erasing this part. Okay, so if this is a sin omega t plus b cos omega t, okay, multiply this with under root of a square plus b square and divide it with under root of a square plus b square. Okay. Now, y equal to this under root of a square plus b square will be out of the bracket, and this will be a divided by under root of a square plus b square sin omega t plus b divided by under root of a square plus b square cos omega t. We can write it like that. Okay. Now this will become our, this is sin omega t na, this will become cos phi, this is cos omega t na, this will become sin phi. Okay, so we can write it as under root of a square plus b square sin omega t cos phi cos omega t sin phi. We can write it as sin omega t plus phi. Okay, that's how we get this. Okay, Chanchal. Now this will be our amplitude. No need to derive this again and again. You just have to remember this formula, that in case of y equal to a sin omega t plus b cos omega t, if this is the SHM, then you can find the amplitude of that SHM directly using this formula under root of a square plus b square. Okay, Chanchal, Lucky, any doubt? Alright then, let's move to this question. Okay, so H is equal to 1000 ampere per meter and B is equal to 0.25 Weber per meter square, and we have to find this relative permeability of this ferromagnetic substance, which is equal to which is given as mu r or denoted as mu r. The relation between this B and H is B equal to mu into H. Now this mu is not mu r, this is permeability of the medium. Okay, this is permeability of medium, and here the medium is ferromagnetic substance. Okay, now what is this mu? This mu can be written as mu naught mu r, or mu r relative permeability can be written as mu by mu naught. Here the reference is mu naught. So if I have to find the permeability or the relative permeability of any medium, I will write in numerator the permeability of that medium divided by mu naught the permeability of the vacuum. So that would be equal to mu r. So I can write mu as mu naught mu r. So this will be equal to mu B is equal to mu naught mu r into H. We have to find this mu r. Okay. And we know what is the value of mu naught. Mu naught by 4 pi is equal to 10 raised to power minus 7 na? So this can be written as 4 pi into 10 to the power minus 7. We already know the value of B, we already know the value of H, we can find the value of mu r. So I will write B as 0.25 is equal to, in place of mu naught, I writing at 4 pi into 10 to the power minus 7. We have to find mu r, and what is the value of H? That is equal to 1000. So this is 1000. Okay, 0.25, that is equal to 25 by 100. 4 pi into 10 to the power minus 7, this is 3 zeros here, so it will become minus 4 into mu r. Mu r is equal to 25 by 100 and 4 pi, right? So this will come here into 4 pi into 10 raised to power minus 4. Okay, this will become 25, 100 is here, 10 raised to power minus 4 is here, so it will become 10 raised to power minus 2, which will become 100 in the denominator, and that is 4 pi. This 4 and this will become 25. This is 625, 25 का square, right? 625 divided by pi. We have to find the approximate value na. So this will be equal to 625 3.14, right? So it should be around what? 200 into 3 is 600, right? So around 200, or okay, so around 200 we have the value of this. 2 into 10 raised to power 2. Okay, 625 divided by 3.14. So 3.14 into 200 would almost equal to 625. That's why the answer should be 200. Any doubt? Okay, students, so this is the end of the session. This was our last class. Okay, so this is the last paper of this phase 2. All right, so we have discussed so many problems here, so many concepts here we have built. Now what you have to do is revise all these concepts, okay, and I wish you good luck for your exam. Thank you.